So we were discussing the polynomials and we have done. Okay. So polynomials in one variable we were discussing, and this is the general form of the quadratic polynomial. This is the quadratic polynomial. Okay. And I told you that these powers should be whole numbers. Okay. Linear polynomial degree 1, quadratic polynomial degree 2, cubic polynomial degree 3. After that, the value of polynomial. Put the value of x in the polynomial and you will get the value of polynomial. Zeros of polynomial means the values of x for which the value of the polynomial will become 0. Value of x at which the given polynomial will become 0, called zero of polynomial. And we have also seen the graphical interpretation of the zeros of polynomial. So zeros of a polynomial is basically the x coordinate of a line. Okay, x coordinate of a graph of a polynomial which is intersecting on the x-axis. Suppose this is the polynomial, linear polynomial x plus 2, and when you will plot this polynomial on the graph, you will get a straight line, and this straight line is intersecting at y-axis at point 0, 2. On x-axis it is intersecting at -2, 0. So basically this -2 will be the 0 of this polynomial. Means the line or the polynomial intersecting at x-axis at a point, and the x coordinate of that point will be the 0 of a polynomial. 0 of a polynomial is x coordinate of a point at which the graph of the polynomial cuts x-axis. Degree of a polynomial, I told you, highest power of the polynomial. For example, in this degree is 2, in this degree is 3. Okay, after that we discuss the polynomial of degree n. The graph px intersects almost at endpoint. Means if the polynomial is having a degree 2, at most that graph at most that graph will intersect x-axis at most at 2 points. If the degree of the polynomial is 3, then the graph can cut the x-axis or intersect the x-axis at most 3 points. Number of zeros of polynomial, I told you that number of points at which the graph of polynomial intersects the x-axis. For example, this is a linear polynomial, and for this linear polynomial, this graph is intersecting x-axis at what point? So this polynomial will have 1 0 only. If this is a graph intersecting x-axis at 4 points, so number of zeros of this polynomial will be 4. We have done some questions also. After that, we did the relation between the relation between zeros and the coefficient of polynomial. Okay, so if this is a polynomial, this is known as the constant term. This is the coefficient of x. This will be the coefficient of x square. This is the coefficient of, this is a constant term. So in case of the linear polynomial, for example, this is a linear polynomial, this is a constant term. So you can write x is equal to -3/4. And what is -3? Constant term. What is 4? Coefficient of x. So x can be written as -b/a. In case of the quadratic polynomial, the sum of the zeros of a polynomial, suppose alpha and beta are the zeros of this polynomial, sum of the zeros is equal to -b/a, product of the zeros is c/a. Sum of the zeros -b/a, product of the zeros c/a. Cubic polynomial, suppose 3 cubic polynomial. For cubic polynomial, at most there can be 3 zeros. So sum of the polynomial is this. Okay, product of the polynomial is this, and alpha beta beta gamma gamma alpha is equal to c/a. And we did some of the questions. This question, example number 2, we have completed. We have completed the example number 2. After that, we have completed the example number 3. After that, example number 4 now we will do. Example number 4 now we will do. For a quadratic polynomial, Azaan, what is the degree of quadratic polynomial?
2.
2. Okay. So for a quadratic polynomial, the sum and the product of whose zeros, the sum and the product of whose zeros are -3 and 2 respectively. Basically, find the quadratic polynomial. We have to find a quadratic polynomial. Okay, we have to find a quadratic polynomial. This time zeros are given. This time zeros are given, and we have to find the quadratic polynomial with the help of zeros. So, okay. So let us assume the quadratic polynomial is this. Px is equal to ax square plus b into x plus c. Because we do not know what is the quadratic polynomial here, so we assumed this polynomial. So basically what we want to find now, the value of a, value of b, and value of c we want to find. So what we will do now, these are the two zeros of this quadratic polynomial. This is assumed, we have assumed let. So alpha you can take -3 and beta you can take 2. Now there is a relation between the coefficients and the zeros of a polynomial. Sum of the zeros of polynomial of a quadratic polynomial is equal to -b by a. So do the sum. 3 -3 plus 2. It is -3 plus 2 is equal to -b by a. So from here what value you will get? It is -1. -1 is equal to -b by a. So you will get b is equal to a. B is equal to a you will get. Now product of zeros, that is alpha beta, is equal to c by a. So product of the 0 -3 into 2 is equal to c by a. So from here you will get c is equal to 6a. C is equal to -6a. Okay, -6a. Now what we can do? We have b and we have c in terms of a. So what we will do, we will put different values of a, and we will get different values of c and b. So put a is equal to 1. A is equal to 1. But here you have to remember this a cannot be 0. A cannot be 0, otherwise this will become a linear polynomial. So a is equal to 1. You can put a is equal to -1 also. A is equal to 1. So what is the value of b? B is also 1. And what is the value of c? C becomes -6. So now you have ABC put in this polynomial. That is ax square means 1 into x square plus bx 1 into x plus c means -6. So the given polynomial, the required polynomial will be x square plus x minus 6. Now if we suppose if I am putting the value phi is equal to -a is equal to -1, put a is equal to -1. So b also I will get -1. B also I will get -1. So c I will get 6. C I will get 6. So the required polynomial will be ax square, means -1 into x square. Ax square plus bx. So b is -1 into x plus 6. So the polynomial will become minus x square minus x plus 6. You can put the value of a as 2 also. You will get a different polynomial. Okay. So basically they are asking find a quadratic polynomial. So this is also a polynomial. This is also a polynomial. Means we will get n number of polynomials we will get. Okay. We will get n number of polynomials. So we can, okay, just put the value of a as 2. Put the value of a as 2. So if you will put a 2, then you will get b also 2, because a and b are equal. Here c you will get -12. Now the required polynomial will be ax square plus bx plus c. So now take 2 common. You will have x square plus x minus 6. Now compare this polynomial and this polynomial. You can say the given polynomial is k times of this value, x square plus x minus 6. So when you will put the different values of k, you will get different values of polynomial. When you will put k is equal to -1, you will get this polynomial. When you will put k is equal to 1, you will get this polynomial. When you will put k is equal to 2, you will get this polynomial. So finally this is the answer. They have different values. They have different values. Okay, Azaan?
Yes.
Okay, so write down fast. We will do one more question, then we will move to the next chapter. Write down fast. This is example number 4. Don't write the question, write only answer.
Done, sir.
You can write k have different values, or you can write, it is better to write k is a real number. K is a real number.
Done, sir.
Done? Okay. So now we will discuss this question, one more question, and in this question also, this is the question number 2 of exercise 2.2. Okay, and in this question also we have to find the quadratic polynomial, and zeros are given. This is the question. These are two zeros. Find a quadratic polynomial each with given numbers as sum of the product of its zeros respectively. So basically, in this question, when you will check the exercise, there are I think 8 and 9 questions will be there. So I have chosen this question. So we will solve this question, and then we will move to the next chapter. So these are the two zeros, and with the help of these two zeros, we have to find the quadratic polynomial. Suppose this is alpha, this is beta, and consider a quadratic polynomial ax square plus bx plus c. Okay, ax square plus bx plus c, and a must not equal to 0. So we know that alpha plus beta is equal to minus b by a, minus b by a. So alpha is √2, and what is beta? 1 by 3, and this is equal to minus b by a, minus b divided by a. Now it will be a problem. Alpha beta is equal to c by a. So alpha is √2, beta is 1 by 3, and this is equal to c divided by a. From this equation, we will get v is equal to minus of √2 plus 1 by 3. And from this equation, we will get c is equal to √2 by 3 into a. And this is here is also a, na? Here there will be also a. So there is no problem in this. We will put different values of a, and we will get different values of b, and we will get our answer. So you can put any value of a. So I am putting a is equal to 1. So when I will put a is equal to 1, so what I will get? B is equal to √2 plus 1 by this value I will get. B is equal to minus of √2 plus 1 by 3, and c what I will get? C I will get √2 by 3 into 1, that is √2 by 3. So you will get your answer, ax square plus bx plus c, na? This is the polynomial we considered, ax square plus bx plus c. Put the value of a, b, c. A is 1 means x square, B is root 2 plus 1 by 3 into x. What is C? Root 2 by 3. This is the first polynomial, and you can write this as, and you will put x is equal to 2, you will put x is equal to 3, x is equal to 4, x is equal to 5, 5.5 you can put. So basically you will get k times of x square plus you will get k times of x square plus root 2 plus 1 by 3 into x plus root 2 by 3. So this is the required polynomial, and k is real number. Understanding?
Yes, sir.
Gazan, so write this, then we will start the pair of linear equation in two variables. No need to write only exercise 2.2, question number second of second. Like this, second and second.
Okay, sir.
In the chapter polynomial, exercise 2.2 is there. Exercise, and this is means division algorithm for polynomial. This is deleted. You can check, and means exercise 2.3 is deleted.
Done, sir.
Done?
Yes, sir.
Okay. So next chapter is pair of linear equation in two variables. Pair of linear equation in two variables. Introduction. So pair of linear equation in two variable. What is this? If I write a into x to the power 1 plus b into x to the y to the power 1 plus c, and that is equal to 0. This is a linear equation in two variable. Linear means power 1. X and y are the variable here, but x is also x and y is having power 1. So what is x and y are variable here, are variable. These a, b, c are the real numbers. And one more thing, this a and b cannot be 0 simultaneously. A not equal to 0, b not equal to 0. You can write here a square plus b square cannot equal to 0. So what is the meaning of this? For example, if you take a is equal to 0, take one quadratic equation. A is equal to 0 and b is equal to 0 and c is equal to 5, and put in this equation. So it will become 0 into x plus 0 into y plus 5, that is equal to 0. Can 5 equal to 0? Never. So that is why a and b simultaneously cannot be equal to 0. A and b simultaneously cannot be equal to 0. A cannot be 0 separately, b cannot be 0 separately, but simultaneously they cannot be 0. So it is this is the form. Okay, telling a and b simultaneously cannot be 0. If a and b simultaneously will become 0, then what will be the condition? This whole term will become 0 and here it is not equal to 0. Okay, now I think you have idea what I want to say. One more example I am taking. Take a is equal to 2, b is equal to 3 and c is equal to minus 6. Now form the linear equation in two variable ax plus by plus c, that is equal to 0. Ax means 2x plus 3y minus 6, that is equal to 0. Now this is a linear equation in two variable. This is a linear equation in two variable. Linear equation in two variable. Two variable are there, x and y, and this is also a linear because power is 1. So basically what is this? This is a linear equation in two variable. Now solution of this linear equation. Solution. The solution of the linear equation is basically the value of x and y for which left hand side of the equation becomes right hand side of the equation. Value of x and y for which left hand side of the equation becomes right hand side of the equation. Okay. If I am putting in this equation, x is equal to 0, y is equal to 0, then what I will get? Left hand side I will get. Left hand side means this side, -6. And right hand side I will get 0. So from here you can say left hand side is not equal to right hand side. It means that x comma 0 is not a solution of the given linear equation in one variable, not a solution. Put x is equal to 3 and y is equal to 0. So when you will put x is equal to 3, it will become 2 into 3 plus 3 into 0, and it is -6, that is equal to 0. So 2 into 3 is 6, and this is 0, this is -6. So this is basically the left hand side. So left hand side is this, so it will become 0. And what is the right hand side? That is also 0. Means this is a solution. Another solution also can this equation have. Suppose put x is equal to 0 and y is equal to 2. So it will become left hand side. So left hand side will become 2 into 0 plus 3 into 2 minus 6. So it will become 0. 2, this is 0, this is 6 minus 6, 0, and right hand side is also 0. So this is also the solution. So there can be many solutions of one linear equation in two variable. Okay. We will see these solutions of the linear equation in two variable graphically. We will see these solutions graphically. What these solution represents graphically. Okay. So basically you can say from here, what solution you are getting? From this, you are getting x comma y value, that is equal to x is 3, y is 0. 3 comma 0 you are getting. From here, the value of x comma y you are getting 0 comma 2 you are getting. Okay, so again I am taking this. Now we will discuss this graphically by taking the same equation. What is the meaning of the solution graphically? So for that we have to draw the graph, and for drawing a graph, there is a requirement of coordinate point. So this is x, this is y. Okay, and what is the equation? This is the equation, 2x plus 3y minus 6. 2x plus 3y minus 6 is equal to 0. So we want 2 points. x comma y. Put x is equal to 0. Put x is equal to 0, so x becomes 0. So it will become 3y minus 6. So y will become 2. Put y is equal to 0. Y is equal to 0. X will become 2x minus 6. So 2x is equal to 6. It will become 3. So we are getting 2 points. One point is 0 comma 2. Another point we are getting 3 comma 0. Now we will plot these points on this graph. So this is suppose 1, this is 2, this is 3, 4, this is 1, this is 2, this is 3, this is 4. Now plot this point first, 0 comma 2. So 0 comma 2 will be x, the value of x is 0 and y is 2. So this point will be this. This is 0 comma 2. 3 comma 0. 3 comma 0 will be this point. 3 comma 0. Now join both these points. So basically what you are getting? A straight line. You are getting a straight line. So this is the solution of this equation. 3 comma 0 is the solution of this equation. 0 comma 2 is also a solution of this equation. And both these points are lying on the line. So basically the points which are lying on the line, suppose here is any other point. Here is any other point, suppose P point, that is suppose x1 comma y1. So this x1 comma y1 if lying on the line means it will be a solution of this equation. So you can write all points on line will be solution of linear equation in two variable. Linear equation in two variables. Understanding what is the geometrical meaning of the solution of linear equation? If a point is lying on the line of this equation, when you will plot this equation on the graph, you will get a straight line, and the points which are lying on the straight line are the solution of this equation. What is the meaning of the solution? I told you. So now please note down. This is chapter number 3, pair of linear equation in two variables.
Done, sir.
Completed. Hello, Azaan.
Yes, sir.
Done? Okay. So if a point is lying on the line, that point will be the solution of the equation of that line. Or you can say, if for polynomial also, this is true. If a point is lying on a polynomial, and that if a point is lying on a given polynomial, then that point will satisfy that polynomial. So in the next class, we will take two lines. We will take two linear equations, and we will take basically a pair of linear equation. And with the help of graph, we will find the solution of those pair of linear equation. Okay. Is I'm getting my voice?
Yes, sir.
Okay, so in the next class, we will take two lines, two linear equations, you can say. And we will see what is the graphical interpretation of those two linear equations. And we will plot the graph, and we will see whether both the lines are intersecting